Hello, you're welcome to Ekidel live stream, and I will say welcome. And my name is Engineer Justice Nwaka, and I'm your presenter for this structural design. As you can see that. Now, on our previous live stream, we performed this building modeling here, and the structural model of this building you are seeing here. We will have to model for the ground floor and the basement and all other floors, and then the swimming pool as you're seeing at the top here. And we didn't do anything about loading of the basement and loading of the of all the swimming pool walls and all that. We didn't do that. So we are going to on this live stream today, we are going to perform the structural loading of the swimming pool walls and also for the basement walls. Okay, I'm going to show you first how to load your basement wall. So right now, as you can see on this basement wall now, the first thing we do is to apply our load on all the basement wall. Okay, as you can see that they are on section by sections. Okay, that's fine. So on this now, I'll then click on the basement wall here, on one of the sections of the basement wall here. I'll then do right click on it, and then you will see, okay, now we are currently on the story 0, so you cannot do anything loading on story 0. So I'll come to story 1 where it is, because story 0 is for the foundation. So story 1 is where we'll have the basement wall. Okay, so click on the basement wall again right now, then right click now, and then you have to do click on the place that says you see here that says edit load. Okay, so I'll click on the place that says edit loads. Okay, that's fine. So why we wait for it to do to appear. Okay, once it's appear right now. Okay, so on this place now, you can see that we'll have several load types here. Okay, to load your basement wall. Okay, but right now I will need to explain this for you now. Okay, that's fine. So most of the times, most people used to apply wrong loading when it comes to basement wall. Okay, which is very bad, and it's not right to do that. So now basement wall basically has doesn't really have wall surface load area. What it has is soil load. Okay, except you are designing for oil and gas sector, that's kind of structure, that's where you have to do apply soil load and also point load, because most times the pipe that is carrying the oil, that is carrying those fluid, can tends to penetrate into the wall, like let me say penetrate through the wall and then continue is flowing. Okay, so with that now, that pipe that passed through that concrete wall is now acting as a point load directly within the point where the pipe passed through. So with that now, that's a point load. So you also have to consider point load at the coordinates, at the point where that pipe will pass through. So you need to apply the force of that crude also on that plate. But right now we are not dealing with oil and gas design. We are dealing with normal infrastructure design, which is building design. Okay, and all that. So with this now, there is not like pipe punching through the walls and all that. So we are going to apply directly soil load on the face of this basement. Okay, so that takes us now to this place that says soil load here. Okay, so on this soil load now, we will just allow it to do to display. Okay, because it will display a different dialog box. That's because we clicked on the soil load. Okay, so let's allow it now to display. Now when it comes to loading, you must be very careful when you are loading your structure. Okay, because if you do a different loading that is wrong, then you have issues on that. Okay, that's fine. Okay, so right now I can see that, and I'll then come here and then click on this place here that says on this surface here. Okay, now on clicking on this right now, it will display a dialog box that we are going to use. Okay, let's just hold on for that to display. Okay, that's fine. So you can see that it has now displayed this load here, but before then I would like to close here first and then do delete every load that we have. Okay, no load here. Then make sure that there is no load yet. Then come back now and then click on this soil load here, and then click on this surface here. Now on this now, then most people tends to do what, tends to just apply their values and all that, not knowing that they are meant to do what, they are meant to make some settings. I see some videos on YouTube, they just come here and apply their load wrongly, very wrong. Okay, very wrong. Okay, that's fine. So right now I'll be showing you the right way on how to apply your load on your basement wall or on your retaining wall based on the type of soil that is found on the region or on the area where the structure is meant to be built. Okay, that's fine. Okay, so with this now, let's now go with what we have now on this. Now you can see that this place now says what, model type, or sorry, model label. This place can be type anything. You can just put in any value here, but me, I choose to leave it as what, default. Okay, then on this place now that says what, load side. Okay, it's basically what, on active and not passive. Okay, because it is the wall that is what, trying to retain the soil. Okay, so the soil is trying to push the wall away and not the wall trying to push the soil away. So with that now, it is an active what, pressure. Okay, then this place that says what, long-term load and short-term load. I'll just use one word to explain this. Long-term load is simply let me say, trying to design for worst condition, while short-term load is what, if you are sure that that basement wall, let me assume that during the construction, knowing that after they have finished constructing the basement and they have done what, backfill, if that's like, let me say, 30-story building, you can see that there will still be other vehicular activities around the basement, for example heavy duty vehicles passing through. So with that now, they are causing load on the soil, and since the soil is being loaded on the surface, it will do what, try to push some soils, and when on trying to do what, perform that soil what, when that soil is trying to do what, move, it will now find what, it will now come and find this wall here, this wall, which is now serving as a retaining wall to now resist the soil from pushing into the structure. Okay, or let me say, into the basement. So with that now, if you are sure that vehicles that are passing through that place is just for a short time, or the load that will act on the surface of the soil around the basement is just for a short time, then you can come here and choose short time. Okay, come here and choose short time. But in my own advice, I would advise to leave it as what, long-term load, because you don't know what will happen later around that area. Okay, and all that. So leave it as long-term load, knowing that we design for worst condition. Okay, generally if you're doing your design of structure, you design for what, for worst condition. Okay, that's fine. So with that now, leave it as this place here that says what, long-term load. Okay, and all that. You can leave every other thing here as default and all that, but if you have your water table level, you can do what, input the value here. But if you don't have it, then leave it as default. Now then move to what, settings here. Okay, I will still walk you through back to the model, because we need to go and get the height of this wall. Okay, but currently the height of the wall have just come here what, automatically to this place at what, 2950, knowing that our height of what, of the story one where the basement is what, 2950. To now show you that, let's now go back to the CAD file now. To the CAD file here, you can see that we have let me just go there right now and then shift this a bit and maximize this. Okay, that's fine. You can see that from our basement here, you can see that our basement here, if I measure now, this is the basement area. Okay, from the top of the slab here down to the top of this slab here, we have what, 2950. So this is how we got our what, height of wall, 2950. Okay, then minimize back now, and on this place you can see that why we have a custom value here, 2950. That's because we have already set all our story heights when we did what, during the modeling of the stories. Okay, that's fine. So with this now, we're now going to do what, move into the settings. Okay, now on the settings here, know that we are using what, European code. Okay, so you have to choose your own code on the code you're using, but for we right now, we use what, Euro code. Okay, and all that, because that is the most recent code and all that. Okay, so that now we now move to what, spectral type, just leave it as what, 2. Okay, type 2. And on this ground type, I'll just leave this ground type, because you only pick this ground type if you are working on, or if you are doing a design for the area that have what seismic or earthquake, okay, earthquake, that's where you have to choose this ground type. And once you choose this ground type right now, you will see your values here showing here, okay. But you can choose to do what, edit them, okay. For example, now I don't want to choose any ground type, because once I choose any ground type right now, that means that I have applied the ground type to this structure, and this is not a seismic structure. We are not designing for a seismic load or our design, okay. So I'm not going to choose that, okay. Don't choose that. Then now move to what soil profile, okay. Now on this soil profile, now you can see that we'll have two soil materials here, which is what, the sand and what, the rock, okay. Now I see most people just putting their values just like that. Now know that if you don't have rock in that area, or where this building is to be sited, there is no need for you putting a soil material as what, rock. You can choose to remove. That's why you have what, remove and what, add. And if you have any kind of soil again, like silty clay or clay, you can choose to come here and add that soil, okay. You can choose that. If I go now, you can see that there is a different soil here. Can you see that we now have what, number of soil. You can now choose to come and do what, add your soil here. Click here and choose the type of soil, because just hold on, it will show the type of the soil layers right now, okay. Just hold on for that. So you will have to do what, choose your type of soils. And if you have only one type of soil, which is sand, then there's no need for you leaving all other soils there. It will affect the design of that retaining wall or basement. So you can see that we have clay here, silt and rocks, okay. So if I want, if maybe I have clay, based on the soil report, there is clay, I'll have to come here and add clay to as a list of what, soil materials here. So you can see that right now that we now have what, sand, clay and rock. So if maybe I don't have rock, I'll have to do what, come here and remove the rock, okay. So for example, now in this building we have only sand, so because of that there is no need for me having rock and sand as my soil layer on this basement. So I'll have to come what, remove all that soil layers and leave only the soil which I what, have, okay. So with this now, I will then come here, click here and then do what, remove, okay. I have to remove that rock, you can see that. Then come again here, click on this place now and then remove also here. So with this now, I have only sand as my layer, okay, as my layer, or sorry, as my soil what, material, okay. That's fine. Then now I'm gonna come here right now, then do what, click here and then type in my what, the height of the sand, which is basically the height of the basement, okay. But if you feel that the sand will not cover the basement evenly, then you can then do what, put the height of the sand, okay. For example, we have partial basement, okay, basement that part of it is what, inside the ground and part of it is what, above the ground. So with that now, that's a partial basement. But if you have a fully submerged basement, then you have to put the total height of the basement here and then press what, enter, okay. You can now see that this is what, a fully submerged what, basement. As you can see from our CAD file here, also from our picture here, you can see that basically we have a fully submerged what, basement, as you can see that right now, because this is the ground floor and there is no basement wall showing here. Because if it's a fully submerged basement, sorry, if it's a partial basement, we are going to have what, we are going to have an opening around the bottom here, okay, either for windows or just to bring what, vent, okay, and all that, okay. And if also check for the other image too that we have here, you can also see that there is no trace of what, basement showing here. Now to now show you fully, right, let's now move on to the CAD file, okay. Now on the CAD file here, okay, you can also see that let me just make it bigger. You can also see that this is the ground floor level, okay, and you can see that it is fully, basically it's fully what, submerged into the soil, okay. So that's why you can see that right now. So I want to use what, okay, you can see that, okay, sorry, you can see that we have what, let me just see that from here to here we have 1 meter, okay, 1 meter above, okay, and 1 point something meters below. Let me just, from here to here right now is what, 1.8 meter, okay. So we have the soil, okay, 1.8 meters, and this is now above the ground level, okay. So you can see that it is not fully submerged, okay, it is what, partially submerged. So 1.8 of the basement is inside the soil and 1 meter is above the what ground level. Okay, that's fine. So let's now go and do what, modify that. Okay, then minimize this right now and then come here and put the height of the level inside the that is what, that is submerged inside the soil, which is 1800. Okay, that's, and then press what, enter. Okay, so this is how we have got our our basement. Okay, and all that. Now we will now move on to the what, to the next one here, which is what, search charge here. Leave everything here, don't put angle. Okay, leave everything here as default, except you are sure that the soil is at what, is at an angle, but our advice, leave it at what, 0 degree. Okay, that's fine. So now we then go over to what, search charge here. So on this search charge right now, you can see that we have different, we have 2 loads here, which is what, point load and what, and surface load. Remember from the beginning of this basement, I explained about what, about the point load, where if you're designing for, let me say, an oil and gas structure, where pipes can also penetrate, the pipes carrying the crude oil or the fluid can penetrate into the walls and then continue its laying. Okay, now with that, now you have to apply point load at that particular place. Let me assume that there's a pipe passing through this through this wall here. Let me say a pipe here is passing through this wall, so you have to apply what, the point load directly on this area. So you have to apply what, the magnitude on this A and G and all that, and also the what distance where they apply. But right now we don't have point load, so we have to do what, remove the what, come here and what, remove point load. Okay, so we have only what, surface load. That's the load that is going to occur around the soil, around the surrounding perimeter of the basement. Okay, so now on the load, now we have only what, surface load. If you check now, you can have that we have different load here. Basically the load that that applies on a basement wall is what, point load, all right, surface load, all right, and then strip load, and the final one here that says what, line load. So these are the possible 4 loads you are going to have on your basement wall loading, or even if it's not basement, as long as it is retaining a soil. These are the possible loads you are going to do what, encounter, either point load, line load, strip load, and surface load. And this this load type now have their functions. Okay, there are places where you're meant to what, use them. Okay, for example, we don't have point load on this because on this building, because there is no pipe passing through the reinforced concrete wall or the basement wall. So right now we have only what, surface load, which is the load that is occurring only on the surface of the soil, which is the sand right now around the perimeter of the basement. Okay, that's fine. So right now, when it comes to basement wall loading, as you can see, I've already told you about the types of the type of load you're meant to encounter, which is the search charge and all that, the point load, line load, strip load, and surface load. And we are dealing right now with what, surface load. Okay, now once you have picked your surface load, that the next thing now is to do what, is to put in your magnitude. All right, this magnitude simply means the load of that surface load. For let me say, for example, if it is a vehicle that will be passing through the perimeter, for example, if your building is close to the road, all right, knowing that the most occurrence load that can pass through the perimeter of the soil is on what, human load, and either circular human load, bicycle load, motorcycle, and what, and vehicle. So in that, now you can now know that among all this type of load, the maximum load that can pass through the soil around the perimeter of that basement wall or retaining wall is what, vehicle, because that's the maximum load among all the loads which I have just called now: human load, bicycle load, someone driving a bike, motorcycle, and then the vehicle. Okay, now knowing that now, and we design for what, worst condition. Okay, so with that, now we are going to deal with what, the vehicular load. Okay, now when it comes to vehicular load is divided into two parts. All right, into 2 parts, and that is what, HA load and what, the HB load. Okay, the HA load are like the are like the minor vehicles, for example saloon cars and all that. Why for the HB load are for the heavy duty vehicles, for example trucks, caterpillars and all that. Those are for what? HB load. And knowing that we design for the worst condition, it is good to use HB load when you're designing for your what? For your when you're picking for the vehicular load. Although if you're doing for when you're designing for what bridges, we use the two loads, HA load and what? HB load, for the design of bridges and all that. Okay, and even at that, you will see that the HV load, which is for heavy duty vehicle, is what they will consider more to use. Okay, now when it comes to such charge load in terms of basement wall or retaining wall, as long as the wall is what is trying to retain a structure, then you will have to use the HB load. And from BS code and Euro code, the minimum such charge load that you are to use is what? 10 kilonewton per meter what square. That's the minimum. You can see that at a default we have what? 30 here. Now I'll tell you how this 30 came to play. Now this 30 comes to play here is because this software, knowing that all softwares, basically Protastructure and other design softwares, are to do what? They are designed to do what? To fight against what? Structural failure. So even if like let me say instead of that building to fail, let it be that that you perform what? Over design. So they tend to do what? Over impute the values. Okay, so this 30 here is too much, okay, as for magnitude of what? Surface load. Because when it according to Euro code and BS code, Euro code and BS code says that, let me, okay, now we are using Euro code, but know that it is the same what principle. Euro code says that now for HA load and HB load, the maximum surface load is what? 10 kilonewton per meter square to 20 kilonewton per meter square. That, so you can pick any load from there depending on the activities you know that what occur around the perimeters of your basement or your retaining wall or structure. Okay, so with this now, knowing that 10 is the minimum and 20 is the maximum, although you can choose to exceed if you know that much activity will like occur there. For example, if crane will be passing there, which is not that common to be passing, then you can then do what? Increase your load. Okay, so for surface for such charge load now, knowing that 10 is the minimum and 20 is the maximum, then I would say you always stick to what? Maximum for the what? HB load, okay, which is the what? Vehicular load, okay, HB load, which is 20. So with that now, we'll put here 20. Now the reason why this software tends to choose what? 30 is because, for example, now that they have known that the maximum is 20, all right, so they assume that since the code has said that the maximum HB load is what? 20, all right, just to design more safer, they want to do what? They want to increase the load by what? Adding 10 additional, knowing that there is no vehicle, there is no load that can reach up to this 30. So this is the highest they can do that. So but for me, I will not want to do this. I want to stick with what the code says, which is 20, because even the code, people that wrote the code have already done their own experiment and also research, and I've seen that 20, which they said is the maximum, can go for any kind of load. Okay, so right now I'll come here and put what? 20 here. Okay, 20 here. Okay, that's fine. So with this now, once I have done this now, that means that the such charge load on this sand, which is being retained by this soil, is what? 20. The load one there is 20. Leave all these places as what? 0. Don't put distance, because if you put distance right now, that means that the load is only running, let me say, from the wall to this area here. Now what if the load runs here, or let me say the load only falling from here to this place here? Now what if the load runs here? So leave it as what? At let it run what? Entirely. Okay, don't put anything distance here. Okay, that's fine. So with this now, I'm going to come here and then do what? And click on what? Okay here. Okay, now you can see that we now have our our soil load now on this place here. This is for the self weight. Okay, self weight load. So leave this as this. So right now, once you have done this loading right now, then come here and then do what? Click on what? Okay. Okay, Now on clicking on OK, just now we have now loaded this soil. Okay, if you hover your mouse now on, we have loaded what, this basement wall section here. If you put your mouse here now, you can see that we have a load there showing there. Can you see that? So you got so next to do right now is to do what, right click here, okay, and then copy what, copy load. They will ask you to what, copy the what, soil load. Okay, say what, yes, copy. Okay, copy it now. Now on copying it now, we will then move on to what, move to clicking on the next wall and hold your control key to do what, pick all the walls except this one you have already done. Don't pick it twice, else it will add the load as twice. Okay, so just do what, then rotate now and pick all the walls that we have here. Okay, pick all the walls here by holding your control key and pick all the walls there. Okay, all the basement walls, and then once it's done picking that side, I'll not turn the other side again. Then I'll not turn again now. Turn here again, zoom in here, click this and click this and click this. That's fine. Okay, and then rotate. Now most times when you do an auto highlight like this, it might not paste the load in all of them. So let's just try first and see by do what, paste here, and then hold on for that. It will display something for us to say okay. Just hold on. Okay, that's fine. So right now I can see that. Let's now check now if the walls has load. So we stopped on this side, so we have not done anything on this side here. Okay, let's now confirm if the walls have their loads. Come here, let's start with this one here. Let's see, hover your mouse on it. Yeah, you can see that we have soil load. Now if I choose to open here now, let me just do that right now and edit load. Let me see that. Let's see, you can see that we have soil load here. Can you see that? Yes, so it's not showing. If I also come now and then come here and click on any of this one here, right click now and edit load, you see that we have soil load there showing there. Let me see, can you see that? Okay, now if I now rotate now to this other side here, which we have not loaded, if I click here now, right click here, you see that there is no anything like soil load there. Edit load, you can see that there's no soil load there. Okay, that's because we have not yet pasted anything about soil load on that line. So now come again now and continue from where we stop here, this other one here, and then hold our control key to make sure we paste the load on every all the wall section here. So this is the right way to model your basement and also to load your basement. Maybe later I can do a video on your basement wall loading and then explain more if maybe you don't get that. So right now then come here, right click now and then come here and do what, paste here, paste, and they'll ask me to paste only the soil. I say yes, only the soil load. Okay, it's there. So if I now come and check any of this now, let me just check any of that. Let's just check here right now, check here, right click here, and then come down and say what, edit load. You see that we have soil load now on that place. Okay, you can see that right now. And even if we check this other one that we did here before, that was not having any soil load, right click now, you see that there's a soil load now because we have done what, pasted that. Okay, let me just do that right now. You can see that we now have what, soil load, right? That's fine. Okay, so with this now we have now modded applied load on what, on all our basement walls. Okay.